In this section, we're going to create the NURBS curves controllers that are going to serve as the surfaces which we interact with on our rig. And we're going to place them all over the body, color code them, and make sure that we follow a basic convention that makes it easy to understand how our rig is supposed to be controlled. So the first thing we're going to need to do is make sure that we have both our mesh and our bones showing. We created two different layers before, which can help us here because we don't want to be able to interact with either one of these. We just want to see them for reference. So for our bones layer, I'm going to click the third button on the layer, which turns it to template so that we can see the bones as little outlines, but we can't interact with them. And then on the geometry layer, we could set this either to template or to render. I like to do render so I can still see a nice solid rig, but I've also had it set to X-ray joints for quite a while now. So those three settings there should get you all set in this position that I'm in. I've already saved this as a new version, so Guy Controls, and I want to show you a different way to iterate your saves that I haven't been using because typically I want to do it more explicitly by manually renaming things to draw attention to it. But there is a button here, File, Increment and Save. As soon as you've made a change, you can click that, and what happens is that it just adds this 0.0001, 2, 3, 4, etc. to your file. If you click this button too much, you can fill your entire folder up with a huge number of saves, which is not a very good thing. So sometimes I don't use it for that reason, and I just want to more consciously iterate my save number. But you can use that button as a much easier way to increment your saves if you want to. All right, let's go ahead and get started creating some NURBS curves. If you haven't used NURBS before, create NURBS primitives creates geometry, which we don't want. We don't want sphere, cube, cylinder, cone, plane, or torus. We want circle, and we actually don't even want square. The reason we don't want square is because if I create one down here, you can see in the outliner that there's this group that if I open up, a square is not made up of one curve, it's made up of several. So when you try to click and select something, you get parts of it instead of the entire thing, and that's not going to be helpful for us. So even if we want to make a square shape, we have to start with a circle in order to do that. I will point out, though, that in Create Curve Tools, all of these curve tools make NURBS curves also. I'm not going to cover their use, but if you wanted to make custom NURBS shapes, then this would probably be the way to do it. Or in our NURBS primitives, when we create a circle, we can just use the control vertices on the circle to shape this. So if you right-click and hold on a NURBS curve, you get these options, which is similar to the edit mode in polygon geometry. We want control vertex. So curve point is a different thing, edit point is a different thing, object is obvious, hull is very different and not really for curves, it's more for geometry. Control vertex, though, is the one that creates these little purple, they're very hard to see against the gray, but these little purple floating points that allow you to shape the line. Now, NURBS are interesting because they're almost always in like this smooth mesh preview mode. Due to the nature of NURBS geometry, they're always kind of squishy and smooth all the time. And so this is useful sort of for nice, smooth looking shapes, but they don't work the same way as polygons. I don't really want to get into it in this video, but just know that they're always kind of squishy feeling like this. So we're going to use mostly just NURBS circles. We can change the shape occasionally. We're going to place them around the body and snap them to important locations. And we're also going to color them, which is a thing that's possible in the attribute editor. So if I open up the attribute editor, we can see NURBS circle displayed right here. We want object display, drawing overrides, and then we need to enable overrides. And way down at the bottom here, we can change the color index. They've actually got the ability now in more recent versions of Unity, or sorry, in more recent versions of Maya, to use an RGB value. So we can just select the color as we would normally. But more traditionally, an index is used, which is just this kind of assortment of colors that are like presets. I would kind of encourage you to just use the index. That way it's more backwards compatible. But if you want a very specific color of NURBS curve, then you can use the RGB value. So if I choose, for instance, let's use a yellow, or yeah, how about this purple? So now the bottom ring glows purple like that. Just display that way. Something relatively visible is usually a good idea. A convention that I've seen many, many times is to color the controllers on one side of the body red and on the other side blue. And I think there's no reason not to use that. Try to avoid colors that look exactly like the selected color, like this mint green is different from this lime green. So that one's probably okay, but all of them are here somewhere. Yellow is a good choice because it's nice and visible. I tend to use yellow for the center of the body. Light blue looks like the edit mode, so be careful of the kind of like, there's the mint green that's like, it's still selected. It can mess with your mind if you choose some of those, so just avoid certain ones of these. So like this dark green's a good one. So I'm going to go for that bright purple for the base controller. I'll use yellow for things that are in the center of the body and red and blue for the left and right sides of the body. Okay. So I'm going to leave this first controller. This one's going to be our root controller, and it's going to stay right here on the bottom in the middle of the grid, right where the skeleton is going to be standing on the ground in between the feet. Sometimes this is really useful as a sort of placement in the scene, and it can also be useful as we did in our walk cycle video for offsetting the walk. So typically put that down there. I will sometimes even duplicate this and make one other object so that I can have one that's completely stationary and one that's offsetting the walk, but it's not really necessary to do that. I'm going to go ahead and select this and duplicate it, Control D, and we're going to move this to snap to the root bone, and this is going to be our primary mover control. So to snap inside of these bones, you can hold down V for vertex snapping, drag from the center circle, and then any bone that is visible should allow you to snap to it, but it can be a little bit fiddly. See, since I have geometry showing, it could be snapping to the mesh, which it is right now. So I'm going to turn off the geometry layer, and now I'm going to hold down vertex snapping. Oh, you know what? I think the template mode for bones is not allowing us to snap, so I'm going to set it to render. There we go. So in the render mode, we can snap to things. We still can't select the bones, which is good, but now it'll allow us to snap. Let me see if it still works with the geometry showing. So hold down V. Yeah, it works just fine. So it'll still snap to the center of a joint when you have that selected. So this one is going to be the primary mover for the body, so the root mover object. I'm going to set this to yellow, some brightish yellow. It's in here somewhere. There it is. Okay, and I'm going to make this somewhat nearly sized to the hip area, but keep in mind, as the primary mover, we select this a lot more, and so we want it to be fairly big, and we are going to have one smaller one in the exact same location, which is the hip sway control. It does actually need to be centered on this bone, even though the action it performs will be a little bit different. Okay, so we're going to make that one just a little bit smaller, and for that one, I'm going to color it. So I've got purple for the bottom, yellow for the center. I need one other color, like that lime green would probably be fine. We'll use lime green for this one. So that'll be like the jaw controller, maybe, possibly the look at control for the eyes, I don't know. But just a little bit smaller and a different color. So both of these are centered on that bone. I'm not freezing transformations or naming these yet. I just want to get them into position. And we'll do that as the next step. All right, so going up the back, we do need controllers for each of the joints in the back. So I'm going to grab my yellow one again, duplicate, and then we're going to snap to the first vertex in the back. Always want to make sure that this is in the right location. Okay, don't worry about orientation just yet. For the back controllers, we could either just scale them down to be slightly larger than the character, like that, or we could make some custom shape. I'm going to actually use the feet as our first instance of making a custom shape. So in this case, just to move nice and fast, we'll leave this as a ring. Okay? And duplicate again, and move this and snap it to this joint. And then that's it for the back because we only have those two. The next one is a neck controller. So I'm going to duplicate, snap to the base of the neck. All right, for this one, scale it down. I'm actually going to rotate the ring. This will be its default kind of position just so it faces in the direction of the meat of the neck. It doesn't have to line up perfectly, but just so it's clear that that is meant to represent something different. And I kind of don't like where the ring is, so I'm going to use the control vertexes, excuse me, and I'm going to move them just up a little bit and scale them down. So what I'm doing by moving all the control vertices is that the pivot point is not moved, the object is not moved. Only all of the bits of the object have moved. So if I use object mode, you can see it's still centered right down there. Just the appearance is slid up here, which I like just a bit more. For the head, I'm going to do the same sort of thing. So let's duplicate this one where I haven't moved the vertices. And I'm going to snap it to this bone right here, the head. And since this is representing the entire skull and moving it around, I'm going to do a slightly more extreme version of that same trick by moving all these vertices. I'm going to move them way up here to create a sort of halo around his skull. And that will be the thing that you select to move his skull around. So visually, this will make a lot more sense that you grab up here to move his head and you grab down here to move his neck, even though the rotation center is going to be all the way down here. Okay, we just want to make it obvious which thing is meant to control what. Okay. All right, for the head, we want a jaw pivot, and then we're going to have some look at controls for the eyes, which are special. So one more time, I'm going to grab a ring that doesn't have offset control vertices, duplicate it with Control D, and snap it to this bone right here. I don't think I got it. Nope. Okay, so let's try again. There we go. I've been hitting F to focus my camera to make this a little faster. There we go, so that's in the correct location. And we also want to move the vertices of this one to represent just kind of the jaw. So in this one, I tend to make like a crescent moon shape by grabbing these vertexes over here and pushing them way over to this side. You could even flip them inside out or make them flat, kind of like that. Okay, and then I'm going to grab all of them, scale them down a bit, like this. And then I'm going to use object mode to rotate this. These will be frozen eventually, but I want it to just line up on the chin like that so it's clear that this is our jaw control. And I'm going to make it a bit smaller still. Yeah, something like that, as if it's just floating right in front of the jaw area. We don't want this right in front of the mouth because we might have mouth controls on other rigs. It doesn't need to be very complicated, but this is just a nice way to get it to look like it's in the right location. When we zero out this control right now, we've got some rotation on X. It'll end up being 0 and it'll face this way, but it doesn't really matter. It should be fine. Okay. All right, let's make some look at controls for the eyes. So first thing, I'm going to duplicate the chest control again, and I'm going to snap it to the same head controller because it's right in the center. I'm going to snap right to here. Okay. Now the eye controls are interesting because they're going to be a point in real space out here that the eyes are going to aim towards. So we have to do this a little bit special. I'm going to snap in Y to one of these eyeball bones so that I have the correct height, like that. In fact, to make sure I'm doing that correctly, I am going to hide the geometry. Okay. But I'm only snapping vertically. And then I'm going to use Z and snap just to make sure that I'm right in between these two eyes perfectly. Okay. The reason I'm doing this will become clear in just a minute, but this is going to serve as sort of the mask for both of the eyes. That's what it's going to look like. I'm going to rotate this controller 90 degrees and sort of make a binocular shape by scaling the whole thing down to where it's just a little bit bigger than both of those. And then I'm going to flatten the top and the bottom. Just like this. Okay, so this represents both eyes. Then we're going to do the same thing, duplicate the chest piece, snap it to one of the two eyes, like that, and rotate 90. There's X. And let's shrink it down. And this one's just going to stay a circle about that big. And we'll duplicate this and snap it to the opposite eye. Okay, so what's going to happen here is eventually the left eye will focus on the left controller, the right eye will focus on the right controller, and this one will move both of the controllers. That way, if you need the eyes to focus in on something, you can move them closer together, or you can cross their eyes that way. Or if you need it to look like they're looking very far away, you can slide them out a little bit, and it will look like they're looking into the distance. Or if they, got knocked, silly, then their eyes can do weird things. Okay, so those three are going to work as a unit, and we'll have to parent them together. So we'll wait until we're freezing the transformations to set those up. But this is just how it looks right now, almost like a little robot. And at the moment, these are also positioned incorrectly. They're inside the head. Just leave them there for now because they need to be parented before they're moved. I guess that's not true. I'm thinking about that. Like, I could just move them out right now, just grab all three. Might as well just move them all out. They don't need to be a certain unit distance away. They just need to be floating in front of the face. We'll just stick them out there. As long as they're all together. Okay, let's go ahead and do the legs. So for the legs, I'm going to grab the base controller here and duplicate it, shrink it down a bit, and move it over to one of the feet. Now, where we put this one can be a little bit tricky because the pivot point of this controller is not going to be on one of the bones. So think about it like this. If I put the pivot point here in the ankle, then when I rotated my foot, the foot would go through the ground, right? And we're going to be using an IK handle because we want solid contact with the ground. What these bones are doing for us is giving us the ability to roll the foot from the ball of the foot, roll the foot from the toe. We're eventually going to have a reverse footlock controller to do heel roll as well. But if I'm thinking about it, I could just put the pivot point back here in the heel and kind of get that control right away. So that's sort of what I'm going to do. I'm going to reset this just so it's back on the grid and move it over. I'm going to snap it to this bone, but only horizontally. And then I'm going to move the pivot point back to where it sort of visually lines up about where the heel is. It's okay that's a bit above. I think it's lining up with the grid just a little bit right now. That should be fine. It would cause a very, very slight sliding and slipping in the heel. You could like lock it right down to that vertex, but I'm going to prefer to put it just a little bit up like these other two bones are. Then I'm going to move the control vertices and create a sort of foot outline. We'll move this forward. We want it to be a little bit bigger than the foot so that we can see it easily, but not too big. And then I'm going to flatten the instep like that, and then just scale in the outside. So we've got one flatter side and one rounder side. I'm also going to, let's say, make it a bit smaller in the back. Like this. Just to kind of get a nice foot kind of shape. Not too detailed, really. Okay. So for this one, I'm going to want to flip this shape and line it up in the same way on the opposite foot over there. So we're going to have to make sure that it's the right color and that we freeze the transformations, when we flip them. But for now, let's just do the other leg controls. The hips are already here, but we don't have a knee controller. In some rigs, what we do is we have a twist control that's located in the foot. And in fact, all of the special controllers that are going to allow us to ball roll, toe roll, heel roll, they're all going to be channels inside of this one controller. So we don't need any extra NURBS curves, but we do need an object that represents the global position of the knee if we're using a pole vector control. So I'm going to duplicate the base controller one more time, snap to the knee, and then I'm going to just move it straight forward to float in front of the body right about here. Knee and elbow controls can be a little bit tricky to position and orient, so you might have to refreeze and reposition these when we put our IK handles on and do our pole vector constraints. But for now, just float it straight in front of the knee, and then we're going to shrink this a lot And because pole vectors are special, sometimes we make this shape different so it's obvious that's what it is and not some controller that's gone missing. The best way I like is to just grab the control vertices and select every second one, and then to scale inside out. But recent versions of Maya, I don't know if they let you do this anymore. They sort of like stop you at 0 and make it go positive again, which I always kind of liked the ability to scale inside out, but a star will do fine. I know there's a way to stop it from doing that, but I don't want to be bothered to find out what it is right now. So this star shape will do for a pole vector control. Same thing we're going to have to do is snap this in X to the opposite knee when we mirror it. Let's get some of the colors working correctly. For the foot down here, I'm going to return to the attribute editor. And you can choose red or blue for the left or right side. Just be consistent. We'll find out which one I find first. So blue I found first. So left is going to be blue for me. And that means this should be blue also to correspond. There are lots of different reds and blues. Try to make sure you pick the same one and a relatively bright one so that you can see it against the gray background. Okay. That means that I should probably just duplicate this now and snap it to the elbow, because your elbow pole vectors should look the same. Snap. And then we'll move it straight back in the case of the elbow. Okay. For our wrist, though, I don't want to duplicate this misshapen one, so I'm going to grab the base controller again. Snap to the wrist. Take a close look here. There we are. Snap to the wrist, and then shrink it a whole lot and make sure that it's oriented around the wrist like a wristwatch. So it looks like 90 in Z for me. Okay, shrink that size, and then just about to here, and I'll turn it blue as well. Okay. One that we haven't done yet is the shoulder shrugging. So grab the wrist controller, duplicate, and we're actually going to snap to the clavicle way down in here. Okay, that's the correct pivot point for the shoulder. So now I want to take the control vertices and move them out and up a little bit over the visible part of the shoulder. And then typically what I like to do is make sort of a semicircle crescent out of this again. So I'm going to grab the lower set, scale them, and move them up, kind of like this. Scale them in a little bit, so that this forms sort of a shoulder pad kind of object. And blue is the correct color for this, but I want to make sure that it rotates from here. There we go. All right, so we're almost ready to go. I guess what I could do, I'm thinking about this one, I could grab the control vertices and I could also rotate them out like that, maybe move them slightly, because when you shrug, it's going to be more likely that this goes inside the head. And so leaning it away a little bit will keep it visible for longer. So that's kind of a good idea. And when we mirror it, then it should line up the same way for the other one. So it didn't change the controller at all. All right, let's see. Anything left? Knees, feet, root, hips, spine, spine. We don't have another spine. Usually I have 3, but this time we have 2. Neck, head, jaw, shoulder, elbow, wrist. We don't have controllers for the fingers. We could have little rings on every single joint to control the fingers. We're going to make a relatively simple control setup for our hands, though, and it's going to be with set-driven keys that are in the wrist. Just know that hands can be very, very tricky to animate, and so you may need a large number of controllers to properly set up your hands. But with this first rig, we're just going to do a simple hand setup. So we're just going to do a set-driven key for curling and uncurling the entire finger, and then probably another one for the leaning left and right. In fact, I'm thinking we could make a simple controller just for the first knuckle of each one. Let's do that. That'll make it a little bit easier. I'm going to duplicate and put a controller on each one of the fingers. So here's one, and I'm going to move the vertexes to be smaller, hover above that knuckle, and I'll also make it that kind of crescent moon sort of shape. So all this one is going to do is control the first joint, and then with set-driven keys inside of it, we'll curl the other two joints. So that should make it a nice, simple kind of setup. Make sure this is relatively small and floating just above that knuckle. Since there's going to be a bunch of them, I want to make it even smaller. Okay, that should be fine. Okay, then I'm going to duplicate this and snap it. What happened? Oh, it's snapping way down there somewhere. I want to turn off the geometry again just for a moment because it's getting in the way. There we go. Okay, and then duplicate and snap. Duplicate and snap. And one for the thumb. Duplicate and snap. Now, if the thumb, I'm going to turn off the template. Okay, I just wanted to check the rotations on the thumb, but the thumb is oriented this way, and so we want the handles of this to face that same way. So we're going to have to worry about the orientation of this controller, because right now it's rotating like this, and we want it to match up. We want to match that orientation. So in a little bit, we're going to have to solve that. But first, let's just get them all in place. All right, so there's my finger controllers for each one. Looking good. Turn my geometry back on. And yeah, at that point, we should be all set for the left-hand side of the body. All right, so now we're going to start naming things, because then the only thing we have to do when we flip it is change the L or the R on the name of it. So this one is going to be the character name. So this character's name has been Guy. So we're just going to say this is Guy, and you can call this a placer or positioner, or Guy master is another one. And I'd usually put control on the end of everything, because you're going to have so many things that are named in here that if you don't differentiate between controls and geometry, sometimes it can get very confusing. So that's the Guy master control. All right, we'll start down here. This is going to be the foot. There we go. So foot L control. I'm going to copy the underscore L underscore control, because that's going to come up a lot. And so I can just paste it at the end of whatever I type. Here's the knee. Paste, enter, knee left control. This one is the root. Remember, no side for that because it's right in the center. These are the hips. Spine 1. Spine 01 control. I don't know. Spine 01 control. Even though we've only got 2. Spine 2. Neck. Head. I think I mistyped there. There we go. And jaw. This is the look at controller. And this is, oh, we didn't color the eyes. Let's color the eyes. Blue and red. See where the brightest red is. It's kind of dark red. Yeah, that one. And so this will be eye left. Oh, didn't put control. Eye left. And eye right. Okay, and we've got the shoulder, or sometimes called shrug, elbow, left control, and wrist or hand, we'll say hand, left control. All right, for these ones down here, we can just name them. We don't have to say that they're the left for each one of them. We'll do pointer. We might as well. I've got it to paste. Pointer left control, middle left control, ring, and pinky. And thumb. All right, so on the other side, we'll just have to replace all of the L's with R's, and we should be good. So checking in my outliner to see if there's anything that was not named. They all look good. None of them are parented in anything, which is good at the moment. Good chance to iterate and save. And so now we can freeze their transformations and worry about mirroring them to the opposite side. All right, we're going to make sure that all of our controls have frozen transformations and rotations. And for that, my bones layer was set to be selectable. I'm just going to grab everything because none of them need to have transformations that are saved right now. Modify freeze transformations. So we just want to make sure, going down this list, that nothing is appearing in any of these fields. So I'm just quickly tapping to the right, which is great. Now for a couple of them, there's something special going on. This controller, nothing special is actually happening right now. It is going to rotate from the place where it is, but it's going to control this bone instead of this one, so we don't have to worry about that. The foot, this is going to control an IK handle we don't have. This is a pole vector. I guess the first really interesting case is going to be the thumb. Maybe it's the only. Yeah, it's the only one, except for the case of these where we just have to parent them. Grab both of the eye controllers first, and then the mask second, and then hit P to parent. And so when we move the look at controller, the eyes will be moved, and then you can move them individually inside. That's all that we need to do there. I think the only special one really is the thumb. The thumb is a special case where the joint that is moving down here is at an angle, and we want this to share those same rotation axes. But if we just do this, then we have non-zero rotations, and that's annoying. And so we're going to have to put this one inside of a group. So let's grab this object, edit group, freeze the transformation of the group. I'm sorry, I meant center pivot of the transformation of the group. There it is, so it pops up here. And we're going to have to name this also because it's going to go into our do not touch folder for this rig. I'm going to name this thumb left group. GRP is fine for that. We're wanting, so the thing about groups, if you're not aware, if I just select like this, you get the object, not the group. You have to select the group from the outliner. We're going to want to change the center of pivot to snap onto the same joint. So insert V, there we go. And now the group is the thing that we're going to get rotated into the correct position so that the rotations of this object remain 0. Okay. Then we're going to make sure that wherever the controller needs to move, the thumb group is the thing moving that controller so that the thumb remains unmoved. For instance, all the fingers are going to have to follow the hand control, or they could follow their own bone, but that would be more messy. So they're going to follow the hand control. Okay, so we're going to orient this group. There's a special way to do this. I'm going to hit Q just so I have selection instead of the manipulators in the way. And I'm going to allow the bone layer to be selectable for a moment because I'm going to shift select the bone. So I've got the group, and the bone somewhere in there. If I open this whole thing, there it is, but take my word for it. I'm going to go up to Modify, Match Transformations, Match Rotation. Okay, so the group essentially has these rotations now, which lines up with this bone. So because it was thumb first, bone second, then the thumb is the thing, the thumb group is the thing that lined up. I wonder if actually, as I'm saying that, I'm wondering if it goes the opposite way too. So let's just try real fast. Bone first, group second, match rotation. Yeah, it actually does. So whichever one you select first is the one that will move. Good to know. Oops. There we go. And so modify, match rotation, match rotation. So the group is rotated. We're going to leave it just like that. We're never going to change that. And the thumb controller, which is the thing that we'll grab whenever we drag, is at 0. And check it out, lined up perfectly with this joint. So when we rotate, everything will work properly. So that's the only really tricky setup in this whole system, I believe. Although, let's go ahead and let's parent all of the finger controls to the hand. So in that case, we'll grab these 4, and then the hand and hit P. But for the thumb, we have to grab the thumb group and hand and hit P. Or we can just middle mouse drag it to the hand control. And you just want to check that the hand control is moving all of the fingers. When the hand moves, it's going to move the wrist, which will move all the bones, so they won't wander away from each other. But we want to keep the hierarchy of our controls out of the hierarchy of our skeleton. You don't want to be parenting things to bones, for instance, because unless it's geometry, that can make it messier when you need to delete out the control structure or bake your animation in later on. Okay, so that should be fine. Yep. And just doing one more check here. All right, so we're going to duplicate all of our left-hand stuff to the right. So I'm just going to do this from the back here to start off with. I'm going to go ahead and duplicate this. When I move this, I'm going to snap it only in the X to the elbow. And let's go ahead and turn off geometry one more time to make sure I'm getting exactly the right thing. Our hand control, all of its contents are actually going to be duplicated, which is great. So I'm going to duplicate, snap to the wrist, and then the only thing we have to do here is flip this transform to -1, and so all of the joints will line up. So that was scale of X, and we definitely want to make sure to freeze those transformations. So freeze those transformations, so now it's facing the opposite way. Okay, so now we want to change the color and freeze the transformation of this one also. What am I doing? Modify, freeze transformation. There we go. And change the names on these. So first, I'm going to freeze the transformations and change the name. So we'll get rid of the 1, change that to an R. Over here, same thing. Get rid of the 1, change this to an R. And opening this up in the outliner will probably help, because then I can go through a little bit more quickly. Just change all of these to an R. If there's a find and replace for just naming things. I think there probably is, but since it's just fingers, I'm going to just do it manually. Sometimes the more primitive way is the faster way, because there's no ambiguity about whether or not it's going to work, and you don't waste time, even though it's just a little bit more labor. Just something for, you know, if you're being a production artist and you think, maybe there's an easier way to do this, research that on your own time. Don't do that on the clock. Okay, if you don't know, just do it the good old-fashioned laborious way that'll work immediately. Let's change the color to red, that bright red, for each of these. Unfortunately, you can't just grab several and change this color. I really wish you could, but no. So you got to do it one by one. And the thumb. Great. So now we've got our left controls and elbow. One note about this one, we're going to orient constrain the wrist to the controller. There is an option to maintain offset. If you take a look at this one, when we rotate upward, it's a negative Z number. And when I rotate upward over here, it's a positive Z. That one matches up perfectly. This one doesn't. But what we're going to do to make sure that there's no errors is always maintain offset when we use our constraints. And so it really won't matter, but I just wanted to point that out because of the flipping. All right. Oh, we're missing a shoulder. Let's duplicate that, snap it to the opposite shoulder. And then we want to, so that this is positioned correctly, flip this one the opposite direction as well. So that'd be -1 in X. And we're going to freeze transformation and change it to be red. There we go. Okay. And that should be it for the upper body, unless I've missed something. I don't think so. Cool. I'm just looking at this. I used green one time, and I'd like to use it once more, I think, for the jaw. This lime green, just because it will make it stick out a little bit. We can see it a bit better. Yeah, that should be fine. Okay, so then going to the lower part of the body, make sure, I don't know if I did a good enough job making sure all the transforms were frozen. Always good to do a double check just in case you're paranoid. And I am very paranoid, so I'm checking. Okay, then for the lower body, so the knee, duplicate, snap only in X to the opposite one, freeze those transformations, and turn it red. Okay. Duplicate the foot, snap only in X. Let's turn it red while this is open, and then we're going to flip it -1 in X and freeze its transformations. Okay, now we need to name the two. So this one is going to be knee R, control, and foot R, control. Okay, so pretty much that's all we need to do for our controllers. I'm just taking a little look at that real quick. Currently, they don't have any relationship to the bones, and that will be the next thing to set up to make sure that they move the appropriate parts of the skeleton around so that the mesh will eventually be able to deform. And once we're done with that step, then we're done with this phase, and that would be the end of the homework for the week as well. But there is one last thing we need to attach to our skeleton in order to have all the functionality we're going to want eventually, and that's IK handles. I've mentioned that the foot setup is going to be a little bit more complicated, and it is, but IK handles first are the thing that's going to help us to eventually move the wrists and the ankles around in space and attach these controllers appropriately. So first we'll do the legs because they're simpler, even though the foot thing will be more complicated. The arms are more complicated because we've got this one extra bone in here, and so the IK handle won't quite work exactly the same way, but I'll show you what that means in just a second. So here's skeleton. Sorry, you want to go to the rigging menu. Skeleton, create IK handle. Notice there's a spline IK. We don't want that. And we want to go to the option box. So that's going to open up our tool settings window. And there are two solvers for IK handles. There's a rotate plane or RP solver and a single chain SC solver. I don't know which one is the default. Let me reset tool to make sure. Okay, the correct one is default, rotate plane. Just want to make absolutely sure of that. So how we attach an IK handle, I can just close that, is by clicking on first the root and then on the distal joint. So from hip to ankle or from shoulder to wrist. So hip, ankle. And what it does is puts this little sort of green line in here. If we look in the outliner, you can see there's an IK handle here. So if we select the joint now, it kind of acts a bit different. We don't want to move the joint. The IK handle, though, here is the thing that we're going to need to name. And when we move it, you can see that the knee bends. So the hip stays put, but the knee figures out what is the angle that it needs to be at in order to be in that location. And then eventually, we're also going to hook up this to control the positioning of the knee also. Let's put that back there. We do want to name this. So this was the left side of the body. So IK left foot or left leg, either way, is what we want for that. And then we need to attach another one. Create IK handle. We don't need the option box for this because we just made sure that all the settings were correct. There we go. And we're going to name that one IK right foot. Okay. So those two are relatively straightforward, and that's the thing that's going to be controlled by this object down here. It's going to control the IK handle. It's also going to control the other foot control setup that we're going to do. All right, so then we need to do one for the arm. The arm can be a little bit trickier because if you try to attach an IK handle from too long of a chain of bones, it could try to bend all of them, though that's what a spline IK is supposed to do, and it does it in a kind of different way. So we may have to do an additional setup step here to make this work. So let me show you the problem. If we do skeleton create IK, this is the shoulder, this is the wrist. Okay, everything's fine and we can move it around, but take a look at this forearm bone that we've got. It's creating another angle. So it's sharing this angle between the elbow and the forearm, and that is not what we want to happen in our skeleton. So I'm going to undo back to the point before I created an IK handle. Something we can do is instead of attaching it to the wrist, we can go shoulder to forearm. And that actually works great. You can see the forearm is no longer bending. Our elbow bends appropriately. The only problem here is that now the locus of this IK is in the forearm, not in the wrist. And that can cause slight problems because it's not really going to behave exactly the same when you're controlling something from the wrist location over here. So the first natural thought you might have is like just move the pivot, but we can't actually move the pivot of an IK handle in the same way that we can an object. You can see that hyperextended it, it moved over there, and now the handle works the same, but it looked really weird, and if I undo, it starts to look really ugly. So I got to go all the way back before I had an handle. So the answer to this is to create an IK handle that goes from shoulder to forearm, but we have to move something called the effector to the next bone location instead of moving the center of pivot. So before I show you that method, there is another possible solution. I'm going to show it to you even though it doesn't work. I want to make you aware of some of the tools in your toolbox. We could try to lock the rotations of this joint and then just attach it straight to the wrist. The problem there is that what we want to use this joint for is rotating the turn of the forearm. And by doing that, even though we're not going to lock that rotation, putting an IK handle through it actually makes it not able to function properly. But just really quick to show you that this is existent, if you go to the attribute editor when selecting a joint, you can go down to limit information and then rotate, and you can set the max and min rotation for all of these different values. X is the rotate that we want to keep. So I'll just put 0 in Y and Z and limit it. And so that means that it can no longer rotate in Y or in Z, but it can still rotate in X. And so we think, oh, that's great. We'll do skeleton create IK handle from the shoulder to the wrist. Try to bend it, and hooray, the forearm doesn't rotate anymore. But even if I try to manually rotate this, as soon as I move the IK handle, it snaps right back because it's being controlled from the outside. And I don't think there's a way to circumvent that except the other method that I'm going to show. So I'll just undo. I know that was kind of a long explanation for not very much, but I just want to show that there are other ways to try to solve something, even though the way that I'm about to show you is going to ultimately be the correct one. So let's go ahead and put that IK handle back on from shoulder to forearm. That's the correct positioning. Then we want to move the effector. And the effector, oh, actually it's visible right here. Usually I have to go through another menu. I didn't realize I would be able to see it right here, but that's the object. Let's see what happens. Oh yeah, I'm now moving it. Well, that's really, really convenient. I want to change the pivot point of the effector. So now I hit insert and snap it to the wrist. Uh-oh, that didn't look good. Let's see if that was correct or not. Let's put all of these translates back. Yep, there it goes, flying away. That was not correct. Maybe I have to move the effector itself instead of the transform. Well, I'm going to undo and try that one more time. Create IK handle. I did see it in here. I wonder if this is actually, should be selecting it. I'll do it the other way if this doesn't work the second time. So here we are in the effector. All right, I'll just try snapping it instead of the pivot point to there. No, that didn't work either. Okay, so we're going to have to do it the opposite way because I think it's not actually selecting it. Here to there. I'm going to go into Windows Relationship Editors. I think it's Connection. Oh, where am I looking? General Editor. Hypergraph Connections. I think that's it. Yeah, Windows General Hypergraph Connections. This is another entire sort of view and interface. I don't really come in here for very much except for exactly what I'm going to show you right now. Here we have the IK handle kind of framed, and there are buttons up on the top. Like this one will show everything in your scene, and it's a lot of stuff. Here's the thing we currently have selected, this IK handle. If I hit this button, then we get the IK, the handle, the shoulder joint, and the effector. And the effector is the thing we're supposed to be trying to select. I think I had it before, so I don't know why that didn't work. So what we're trying to do then, once we can click that and select the effector, is we move its, I believe it's its pivot point to this other wrist, and then it should make the IK handle appear to move from that position, hopefully. So insert, yeah, it worked this time. And now I hit insert again, and there we go. So now when I select the IK handle, yeah, the IK handle feels like it's over there, even though it's not. I don't know why that method worked and the other one didn't. I guess that menu that I just happened to see wasn't actually doing the right thing, but that's the correct way to do it. And I know that was a little bit long, so let's do it one more time from the top the correct way. I'm going to delete that handle out. Uh-oh. Okay, so I deleted the handle. It didn't delete the IK system. That's why these are still orange. I'm going to actually have to undo back to the beginning. This is why we save off, and lots of things can go wrong. As soon as those bones turn blue, I'm back to the start. So one more time from the top. Let's just open up that menu, or no, let's do it step by step. So we're in our rigging menu. Select Create IK from shoulder to forearm. Okay. Then Windows General Hypergraph Connections. Okay, here they are. It should frame up what you want immediately, but if it doesn't, then make sure that you have your IK handle selected and hit this little button, which will show these. The effector is right here. Just left click it to select and move this aside. Now that it's selected, we hit insert to change the pivot point, V to snap, and move that to the wrist bone. Turn off insert and don't move it. You're still moving the effector. Select the IK handle again, and now the IK handle thinks that it's over in the wrist. Okay, so this doesn't need to be locked or anything, and it still doesn't move. And the whole IK behaves as if it's moving from a different position. Okay, so one more time, let's do that for the opposite arm, since we know that we've got to set this up anyway. Skeleton, create IK, shoulder to forearm. I have the window open over here, Windows General Hypergraph Connections. So here it is. Oh, it appeared in the same place. That's confusing. So I'm going to hit this button. So we have the correct one. The effector, we select. Insert, hold down V to snap, drag from the center, snap it to the wrist. Insert, don't move, select the handle, and now it all moves correctly. Okay. So I know a little bit complicated, but that's the worst of it for now. Okay. We have all 4 IK handles. We didn't actually name these top 2. So this one I'm going to select, and it ends up being, you do it from the channel box, IK L hand, and this other one IK R. Go. Okay, we've got our IK handles, and we've got that kind of complicated setup done. So actually, I'm thinking that we could also limit the rotation of this just to be absolutely sure. I guess since I was just talking about it, we might as well. We're only ever going to rotate this way on this bone anyway. So I'm just going to open up the attribute editor, go to limit information and rotations. These arrows put the current value in the left and right field. So putting zeros and then turning on the limits means that this bone will never rotate in an inappropriate way. It'll only ever do this. We're not going to have a controller that does that, but it's just a nice extra step. So we'll do that over here as well. Make sure that we place the zeros and limit the bone so that it can only rotate in this way. Okay. So with that, we're ready to start actually hooking up our controllers to our skeletal structure. For setting up the wrist control, I've jumped ahead a little bit to show you the end result because we're going to have to use something else to control the rotation of both the forearm and the wrist called expressions. So here's the end result we're looking for. For one, we can move this around, and of course the forearm doesn't bend in the middle. And when we rotate the controller up and down, doesn't affect the forearm. Left and right shouldn't really. And then twisting, there we go. We can see it's distributed between the forearm and the wrist. The way that this is happening is with an expression. That's the purple tag here on rotate X and the purple tag here on rotate X. Basically, that expression is saying whatever this rotation value, half of that is applied to rotate X for each of these two. So if you add them together, because that's how bones work, when this one rotates, that one rotates, then this one rotates, then it's the full value of the rotation, okay? The full value of the rotation on X anyway. So we have to set that up because constraints won't work in this case. For this object here, we have constraints on rotate Y and rotate Z, but you can't have a second differently weighted constraint, and you can't have the same kind of constraint twice on the same object. So we can't have two orient constraints or 2 point constraints with the same object. You can have it with different objects. So we could have a orient constraint with a second object, and it could split the difference with weight, but you can't have it with the same one, and that's kind of what we would be doing here. So we're going to use expressions, which is kind of a good excuse to just use them and teach how to use expressions anyway. They're a very powerful tool. We're writing just very simple code. I'll show you exactly how to do it in a moment. But it means that you have full control over whatever sort of effect that you want as far as relationships between your objects goes. First, I'm going to show you how to remove this. I've just zeroed this out, and I'm going to remove all of those relationships so that we can just do it fresh. On the channel that has my expression, I'm just going to right-click and break connections. But for the constraint, there's a different way. You can go up to Edit, Delete by Type, Constraints. Always be careful about deleting by type while we're rigging. We don't want to delete history for the most part once we've started rigging, because history is where the relationships are saved. But constraints, in this case, is going to remove those two relationships so we can make them fresh. And then over here, I'm going to just select that channel, right-click, and break connections so that I no longer have the rotation part of this setup. So here's the IK moving around. The IK handle is just point constrained now, and no rotation is happening. And if I rotate, it just completely ignores it. Okay, so I'm going to reset that. And now we're going to set everything up for the wrist. So we need to have our rigging module menu open, constrain. We're going to go for orient, option box. And the two objects I want are first the controller, hit Q so it's easier to select, and second the wrist bone. Make sure it's the bone. There's a lot of overlapping stuff here, so if you're at all not sure, use the outliner, open everything up, make sure that you can see everything properly. So it's already actually set because I did this earlier, but what we want is to constrain only y and z at a weight of 1. Okay. We hit apply, and that means that rotating side to side and up and down is perfect, but this way does nothing. Okay. There we go, all reset. And that's the only constraint that we're going to need because the other ones are expressions. So expressions are placed on the receiving object, on the receiving channel. So you have to select the object and the channel first, then go up to Edit, and Expressions is the first option. If you just select the object, it's grayed out. So, Channel. All right, so Expressions brings up this little window in which we can read the name of this object as referred to in code right here. If you select a different channel, it will change whatever that is. So we want rotate X. We're going to copy this. And this is the receiving object, and it's going to receive information from this one. So this is the name for the controller that's going to feed the data. It is case sensitive. It has to be written exactly. If you want to open a notepad and just copy paste this into there and then copy paste it back, then that could be helpful. But it shouldn't be a problem. I'm just going to highlight this in the outliner and make sure I write it correctly. So grabbing this bone once more and rotate X channel. So we want to paste that down here, wrist_L.rotateX, space equals space, and then, oh, it no longer highlighted over here. It was my hand control. Where did it go? Hand_L_control for me. So whatever you named yours, make sure that it's exactly spelled that way. So this would just make the wrist match the control, but we actually want half of that. So I'm going to do /2. So this is just saying divide by 2, and a semicolon at the end is the way that you write out these code snippets. Okay, so this is the whole line with my spelling and capitalization. Make sure it's exact. Wrist_L.rotateX equals hand_L_control divided by 2. So this equals half of this X rotation. Oh, I actually made an error. This has to be dot rotate X also. Good thing I was rereading it. All right. So it's rotate X equals half of rotate X. So I just copied that whole line because we're going to have to paste it and rewrite it for the wrist and also for the opposite side of the body. So I'm going to hit create. And without closing this window, I'm just going to check that that worked by rotating this to 60. And then clicking on the bone to read, it should be about 30, and it's purple. Perfect. We'll set this back to 0. All right, so now we're going to do the same thing for the forearm. I'm going to paste that whole line again, only this time it's going to be 4 L, rotate X equals hand L control dot rotate X divided by 2. There we go. So now when I rotate this one sideways, we'll rotate it to about 40. There we go. This should be about 20. Great. And this should be about 20. There we go. Easy as that. Okay. So now I can move this control around and rotate it however I like. And the rotation is distributed down the forearm. This is, if you didn't catch it earlier, to simulate the radius and ulna bones, which cross over in your arm from elbow to wrist. And so it will create a lot nicer looking model deformation when we animate this. Strictly speaking, you don't need this bone if you're going to build a simple rig, but it's a really good step to have it, and it's a good learning opportunity to figure out another part of 3D rigging. Let's do the same thing over on this other side, since we've got this expression editor open. First, I'm going to do the constraint because it's the simpler part. So constrainer, then constrained. Orient, and it is just Y and Z, which we already have set. Maintain offset is important though, because this one is the mirrored side. Okay. So that appears to have worked. Oh, that one's already rotating. I think from earlier, I must have already set this up. Let me break that so that we can redo it one more time. There we go. That means that that constraint was probably already on there. But it seems to be functioning properly. See, I don't think you can make double constraints. If you try that, then it reauthors the original one on the same object. All right, so now we're going to do our expression again. So on this side, we can see that it's wrist r.rotatex. I'm just going to paste and change that, r. And we're taking it from hand r, control rotatex. So I'm going to copy that and hit create. Okay. So that should work properly. And then we'll apply it to the forearm bone. So this is 4.r. Okay. And that should be it. There we go. So I'm going to just make sure -40, -20, and oops, I grabbed the thumb bone. -20. There we go. And to reset this now, we just hit 0. And we're good. So both of our wrist controllers are working properly. We can move the IKs, we can rotate the hands, and there's nothing strange happening. So that's a great time to increment and save. Okay. All right. We did not set up our fingers yet, and that's going to utilize set-driven keys. So that's what we're going to do now. So first, let's make sure that the orient constraint for each of the fingers will control the first joint. So this is just the same as we were doing. Constrainer, then constrained, orient, but we just want to constrain all 3 channels. So we're going to hit apply. Let's just test. There we go. So we can twist and rotate the finger. We're typically not going to want to twist the thing, but as long as you have the ability to do it, then it's fine. Just choose not to animate that if you think it looks weird. So then going down the line, control, joint, apply, control, joint, apply, control, joint, apply. The reason we're not hitting add is because that would close this window. Control, joint, apply. Now, why not just do the other hand while we've got this open? Just go slow enough that you can make sure that you're selecting all the right stuff in the right order. I'm pretty confident. There we go. So that should mean that each one of my fingers can now rotate properly. I'm pretty sure those were all right. Oh, the orientation on this one is, why is that so weird? Let me check the other thumb. Well, I must have done something wrong on the right thumb because this is correct and that one is not. Just real quick, while I'm in the middle of fixing all of my finger joints, I remembered why this was not oriented correctly and realized that everyone else will have the same problem potentially. When we froze the transformations on this controller, which had this as a child, that's when it froze the transformations of everything inside of it. So all you have to do then, delete the group that contains the thumb control, duplicate one of the other fingers and name it thumb, and then snap it back over to the thumb joint. Then regroup it and modify center pivot and change this pivot point to snap to the joint also. Okay, and on this group, we're going to name this thumb group, or thumb R group. I don't actually remember, but since it's not something we're ever going to select or animate, it's not really going to matter. And then we're going to match this rotation to the joint. So group selected, joint selected, modify, match transformations, rotation. So that rotated in an odd way. It's completely correct, but the controller's upside down, I guess. Okay, so to fix that, me just grab the thumb controller. Looks like I need to flip it negative y. I guess that makes sense because of the mirroring. So -1 in y for the actual controller, not the group. And then for the actual controller, I'm going to freeze transformations. So now I just want to check, is it rotating in the right way? Now it is. And the group is still rotated off in this weird direction, but we don't have to worry about that. That's just going to keep the controller oriented properly. So there you go, just a way to fix that thumb controller. Sorry about that. I know that if you were following my directions, you probably had the same problem as me. So there's how to fix it. Now I'm going to set up all the rest of these fingers and we'll continue on with the rigging lesson. So for adding a set-driven key, we're actually going to create a new channel in the channel box that's named specifically the way that we want it to. And you can create as many as you want. They can support toggle switches such as the visibility, which is off and on. That's called an enum. Or actually that one is a bool. A Boolean is off and on, but an enum is like a list, like a drop-down list. You can have a fractional number. So such as these rotation numbers have decimal points. Or you can have an integer, which is just supporting whole numbers. So we're going to grab the control, edit, add attribute. And so in this menu, we're going to name this, we're just going to name it bend and leave it as a float. A float is a fractional number. I like to set a minimum and maximum value so that it's kind of predictably constrained. I'll set the minimum to, so here's the question. This is going to bend the other joints of the fingers. Do we want to be able to hyperextend the fingers? I kind of do. It's going to look really ugly, but I like more animation control. So I'm going to set -5 as the minimum, and maximum is going to be 10, and the default is going to be 0. Okay, I'm going to hit add. Now, I want to do that to each and every one of the controllers. So it occurs to me now that what would have saved time is if I did that on this one and then duplicated it to all the other fingers, but it just means that I'm going to have to write this over and over and over again. So it's a bit annoying. Let me see if we actually can add the same channel to several controllers at once. I don't really think so, but I'd like to test it just to save time in case it's possible. So -5, 10 is a float called bend, add. Ah, it did. Okay, so we can grab as many fingers as we want. So I'm going to grab the thumb controller and the other 4 finger controllers over here and just write it one more time. Never quite know what's going to work and what isn't going to work. Okay, and add. So now all of those fingers have a special channel called bend that ranges from -5. By the way I'm changing this value, when I select the name of a channel, you can click down middle mouse and scrub left and right to change the value like it's a slider. -5, 10. Okay, so now that we've got our channel, we need to set up this set-driven key. This is not going to control anything to do with this first joint. It's only going to bend the second 2 joints. So we need our animation menu, key, set-driven key, set. So we need the option box for this. So that brings up this interface, which we're going to leave open for a while we set all of these up. We have 2 sides to this interface, the driver and the driven side. The driver is the thing that changes, and the driven is the thing that will change in response to that. So we are going to load the driver as this object by clicking this button when it's selected. And you can see a list of its channels, and we're going to select the final channel, bend, as the one that we're going to use as the driving channel. Then down at the bottom, we want to load the objects that should change. That would be both of these 2 joints, this one and this one. This last one is just the tip, doesn't matter. Load driven, okay, here they are listed. Now you actually can select both of them at the same time, and then we just want to affect which channel. Rotate Z. Okay, so we're going to select rotate Z. So with this channel, these 2 joints, and rotate Z, now we're ready to set the relationship. We want to make sure that the bend value is at the appropriate number, and these are at the appropriate angle. So right now, 0, nothing, and these are straight. Then we hit key. Then we change this value. So first I'm going to go negative, and I'm going to grab both of these and rotate them to how hyperextended maximum I want. It's going to be about that. It's a bit gruesome looking. It'll be fine. I'm not going to animate that far. It's just so that we have that ability. Then we hit key. So now, when I move this number from -5 to 0, we see it changed. So I'm going to go all the way to 10. You just want to do the outermost limits for the most part. If you have some more complicated kind of transition, then you can set as many keys as you want. But I'm just setting them at 0, -5, and 10. So 10, I want to set these to be as curled under as possible. And that would be to where they start to make right angles, maybe just a little bit further than right angles. So about like this. Don't want to go much further than that. And then I'll hit key. So now here we go. -5, 0, and 10. So I've got the ability to aim and orient my entire finger and then determine how much bend I want it to have, which is pretty much enough control for a simple finger. And then to zero this back, we just type in zeros, type in zeros. The only other thing that we could do with this controller is we could lock and hide the channels that we're never going to use. For instance, we're never going to scale and we're never going to translate. So I could right click and do hide selected, or I could do lock and hide selected, or I could just make selected non-keyable. Any combination of those, you can hide and make non-keyable, for instance. Lock and hide would be the most typical. So what it does is it reduces the visible number of channels down to just the useful ones. And in your graph editor, it'll make sure that those are the only ones we see also. So that's a really good step. I believe that's another one that we could do en masse at the end, but I just wanted to mention it here. So let's go ahead and do those same steps for each one of the fingers. I'm going to load driver for this controller and select bend. Then I'm going to make sure that I carefully select the two joints and load driven, select them and rotate Z, which should be, yeah, that's the correct channel. Rotate Z. So we got bend, rotate Z. I didn't change this number, so we key. Then we set it to -5 and rotate them to hyperextend. Then we set this to 10 and we rotate them as curled in as we want them to be. About there is going to be fine. And then we just test it. Yep. And then reset it to 0 and move on to our next finger. So it's not too slow to do all of these, but it is tedious. A lot of rigging can be. So you just kind of, whoa, I hit the wrong button. Don't want to zone out. So you'll get into a rhythm eventually where you can just do it nice and quick. So we know it starts at 0, so we key, change the value first, then change the object. Key, change the value first, then change the object. Right about there. Key, then test. Okay. So what happens if you incorrectly set a key on this set-driven key interface? Well, we can fix that. If you select the object that is receiving those keys, so either one of these two, and have the graph editor open, you should be able to see those keys that you set. So this means that you could also edit them if you didn't like them. So here's the first position, here's the middle position, and here's the last position. And we could do that over here. So what's happening right now is the graph editor is showing this ease in, ease out graph, which means that as I change this number, it gets close to, but then starts to cushion into that final position. So it changes less and less and less. And the same thing's true over here. It gets right through the middle and then changes less and less and less. That's perfectly fine. There's nothing wrong with that. But we could change the way that that is interpreted. If we select in the graph editor and view this, highlight all of that and change it to linear, for instance. So now as I change my driving number on this finger, it will just change an equal amount until it hits the limit. Bonk, bonk, like that. Or we could delete those keys entirely just by deleting them right out of the graph editor, and then they're gone. So the set-driven key relationship will no longer exist if we just delete. So now, yes, these are rotated because I did it at a moment when they were not 0, so I'm going to turn them to 0. But when I change this bend value, it doesn't care. There's no relationship now. So we would have to do it all over again. Okay, so just a little note for you. Doing the thumb should be exactly the same as long as your orientation is correct. You change the bend value, and these should be oriented over on their side so that when you rotate them, only rotate Z is moving. Just a small note in case anyone has problems with this. If you hold down the manipulator key for the tool, as in rotate, that would be E, and then hold down left click, you get this menu that will allow you to change how rotate is behaving, how the rotate tool. So if we change it to world, this would make it impossible to do our edits correctly, but rotate is typically set to object, and so now it's correctly oriented along the pivot point. Same thing can be done with translate, which is typically lined up with world, but you could set to object, and scale has options for this as well. But if you start messing with that stuff, be aware that you've done so, and you can change it back because it can get very confusing and frustrating if you don't. Okay, so I'm going to go through and set up the rest of these fingers off camera, and then we can move on with the rest of the setup for our rig. So now I've got all of my fingers set up, and so I'll just show really quick. If you grab all of the controllers at once, the last one I grabbed was the one that had all the hidden channels, which is why I'm not seeing the rest. It's also because if you multi-select, only the compatible channels are the ones that are shown, which is why it's a really great benefit to name this bend channel the exact same thing, because we can do this and just test them all at once. If you check the bend and don't like how far a finger is going, or it's going too far, remember that all you have to do is select. For instance, this pinky's going a little further than the rest. I don't really care, but it's a good demonstration. I'm going to grab both of those and open the graph editor, and then I could just decrease the amount of distance that this is covering. So this is the negative value right here. So if I move that back down, now it's like in line with the rest of the fingers. So we can make this go further or less far. Just don't change the 0 one. The rest of them edit to your heart's content. So you can animate all of them at once like that, including the thumb, by the way. There we go. And if you've got them set up exactly right, you can also animate like rotate Z. So all of them are coming up and down in the same amount. I actually have this flipped on the opposite side for some reason because of that problem with the thumb, but it's not really a big deal. We don't need them all to move the exact same way. It's nice, but it's not required. So over here, the bend works properly, of course. And then rotate Z just goes the opposite way, but meh, I don't really care. It's going to be fine. I'm not going to need to do that. So there we go. We have perfectly set up hands, orienting properly, using all of their fingers, moving their IK handles. So the only thing we haven't done yet is the pull vectors on the arms, which is the thing that we're going to do next. The pull vector is a special kind of constraint. So we're going to need to be able to see our IK handles in our outliner because that is part of the selection. It's getting a little too complicated to visually select these here on the screen. So just make sure that you have them in your outliner. It's also a good time to increment our save before we do something new like this so that we know we can always come back to the previous version if there was a problem. So just like all other constraints, we need the menu. Pull vector, let me just check. There's no options, it's just a wait. So we don't even have to have that menu open. But we need the constrainer selected first and the constrained object second. So this is IK left hand right there. and we're going to do constrain pole vector. Just making sure, yeah, so the existing constraint there is point constraint. So we're going to do constrain pole vector. Okay. If you see the arm jitter or move, it's because this controller was not perfectly snapped and lined up, or the arm was misaligned. That can happen. The reason we're doing this now is because if we had already bound the mesh would permanently be in a sort of distorted state, and we don't want that to happen. But if we do this and this jitters just a little bit, then we bind the mesh, it should all work fine as long as it looks fine. So now what we can do is move this controller, and the elbow rotates to aim wherever we put it. It needs to aim away from the object, so keep it a good distance apart. But if we bend the arm and then move this, left and right doesn't do very much, up and down, because we're going around this axis. Okay. So if I aim the elbow over there and then move our arm, the elbow tries to continually aim over towards this. And then to reset it is easy because we've built nice controls that we can just zero. Okay, so now we've got essentially a fully functional arm. We've got the ability to shrug, move and pose our hand and our fingers, and control where the elbow is trying to reach. And we can easily reset all three of these by just entering zeros into their transforms and rotates. There we go. That's also an argument, by the way, for not getting rid of channels you're not going to use on other controllers. If the elbow doesn't have rotates, like let's just lock and hide the rotates for the elbow for the pole vector, and now we grab all three of these, and I want to reset. Well, I can't just grab all of those channels all at once and reset them because there's missing channels now. So it's an argument for not doing that extra step on certain ones because it will make the resetting workflow harder. But for the fingers in particular, I think it's fine to do it because they're not a part of the larger kind of pose of the character. But it does mean that eventually if we select everything, then we wouldn't be able to reset the entire character because we've got locked and hidden channels. So if you want to know how to undo that, because I've really only done it on that one finger, we can come up to Edit Channel Control. And here are the keyable, non-keyable hidden, and non-keyable displayed. And you have to just go find the ones that you hid. They would be the translates, these three, and then we just move them that way. So now they're back and they're hidden. Also the scales, XYZ. Here we go. And on the locked side, these were the locked ones. We can just move them. So now they're revisible, available, not locked anymore. And so if we were to select many different objects, we can reset all of that. Scale is one, though, that we basically never use with our animation rigs. So you could get rid of scale for just about everything, literally everything, and it wouldn't cause a problem. Scaling rigs is a fraught thing that you have to handle in a special way. If a rig scales at all, then it usually is done down here with a special channel that controls moving the correct things in the correct amount. Or once you bring a rig from Maya to Unity, you can scale no problem because it's just treated as one big global object. Okay, so there we go. There's the pole vector set up on that arm. Let's do it again over on this side. So we want to grab our pole vector and our right hand IK handle, constrain pole vector, and then just very quickly test that it's doing the right thing. Always want to test, always a good idea. Here we go, shrugging works. And so now I can reset all three of those. There you go. Okay, let's see. And then we've got our feet. So I don't think we set up, we didn't set up anything on our feet yet because we've got to do the reverse footlock controller on the feet. Okay, so that will be, I believe that's our last thing for the entire body. Yeah, we've got the hip swing already. We've got the body working the jaw. I think we did. Yep. The head, the neck, yep. And the aim constraints. So yeah, that will be the last part. And then we've got a fully set up character. So really good time to increment and save so that we can approach the rigging of the feet. All right, so our last setup is for the feet for a reverse footlock controller. And that is a special name for this type of controller. I'm going to link to some documentation that goes over these steps in a different way. But typically it's done with a second set of bones. I'm actually going to do it with locators this time, and I'm just going to show you where to create locators. Up here, create locator. All a locator is a point in space with a rotation and a scale. And when you think about it, that's kind of all a joint is also, just that they're parented to each other. We're going to use a locator because they're visually distinct from joints, and it's going to make this setup a little bit easier. And also it's going to help not confuse you when you have multiple sets of bones visible on screen, and students are always wondering, well, which set of bones is controlling the mesh? And really, it's just this one. The bones that you already see, those are the ones deforming the mesh. You can have different skeletons to control that base mesh in different ways, such as if you wanted a squash and stretchy mesh or something like that. But we're just going to use these locators. They're pretty big when we spawn them in, but we're going to shrink them down to a reasonable size, and they'll be visually distinct from the joints, so that will help as well. All right, so first thing we need to do, though, before we create those locators is we actually need a couple more IK handles on our feet. And this is a weird aspect, but if we don't do this, then when we move our foot around with our extra controllers, it's going to behave poorly. So we have to go to skeleton, create IK handle, but this time we want to switch it to single chain solver, because this is where our IK handles are going to go. They're going to go from ankle to ball, and then we're going to do one more. Skeleton, create IK, from ball to toe. Now, that might seem pointless because they're just one joint away from each other, but it's not. It means that we can control the position of each joint, and the distance doesn't matter, and the orientation isn't affected. That's the big thing. The big thing is that we didn't want the rotation of the joint to be affected. We just want it to be the positioning. But for one reason or another, if we use a point constraint directly on the joint, it starts to behave badly. So this is going to be a better setup. So let's just do that for both of the feet. Skeleton, create IK with single chain, ankle to ball, and then ball to joint. And that's all we got to do there. Now, it did create a bunch of new IK handles down here. So we want to name them so that we don't get them confused with our other four. So this one is going to be reverse IK. Let's do IK. This is the left. We'll do reverse first. REV left ball. This one's going to be IK reverse left toe. IK reverse right ball. And IK reverse right toe. There we go. So we've got these four and these four, which are our primary ones for our body. Okay. I'm going to get rid of that big clunky tool menu over there. All right, so now we want to create our locators for our feet. We're going to create locator. Ooh, where'd it go? There it goes. All right, I'm going to just scale it down. But when we freeze our transformations, the scales are going to pop back up, and we might have to scale them all down again. It's okay. We're going to just snap these to all of the visible joints down here. So snap one to the ankle, duplicate, snap it to the ball, duplicate, snap it to the toe. Do the same thing for the opposite side while you're creating them. We will have to name all these, but quicker to do this way. Then duplicate the final one, and we want to move this back to the position that our pivot point is at for the controller. So I'm going to turn the geometry back on and move this back. And rather than try to figure out where that is or snap to it, I'm just going to move it to a position that makes sense. I'm keeping it level in my case. Okay. And then I'm going to do the same thing with the opposite one. Duplicate, move it back. If you want to, we could snap the Z position, I think it is, to the opposite one so that they're at the same level, but it doesn't really matter. Then I am going to change the pivot point of my controller. Right now our controllers aren't controlling anything, so that's great. I'm going to change the pivot point and snap it to the locator. That's just the easier way to go about it. So now they're perfectly matched up. Okay, and make sure to exit that mode. Okay, so we got all of our locators, and they need to be frozen and named. So here's the naming that we're going to do for this. I'm going to say LOC for a locator, right? So this is going to be our locator for our left heel. I'm going to copy this part of it so I can paste that over and over. Locator left heel. Locator left ball. Locator left toe. Locator left ankle. Same thing over here. Locator right. Copying that. Heel. Locator right ball. Locator right toe. And locator right ankle. So at that point, here they all are in our outliner. I can select them all more easily that way. I'm going to freeze their transformations. There they all go, getting huge, and I'm just going to scale them all back down again. We don't even have to freeze the scales. You can leave them a little bit bigger than the joints so that we can see them clearly and select them. But that's going to be fine. I'm just going to leave them all scaled like that. All right. So now we need to parent them to each other, and there's a specific order we have to go in. The heel is going to be the parent of all of them. The heel is going to be the parent of all of them. The toe is second. The ball is third. The ankle is fourth. Okay. So I'm going to select the ankle, then the ball, and hit P. The ball, then the toe, P, and the toe, then the ankle, P. So if we look in our outliner, the heel moves all of them, the toe is next, ball is third, ankle is last, in that order. The reason for that is when we do our heel roll, we want the entire foot to raise and lower off the ground. When we do our toe roll, we want the same thing, but we won't be using our toe and our heel roll at the same time. If you do, then you get this weird floaty thing where it goes wherever it wants. We want our ball roll to lift the ankle and move it around, but nothing else. And then finally, our ankle doesn't move at all. It just controls where the IK handle goes. Okay? So one more time, that same parenting structure. Ankle, then ball, P. Ball, then toe, P. I thought I did it wrong. And then toe, then heel. So then I just want to check one more time. The heel moves everything. The toe moves everything except for the heel. The ball moves the ankle positioner, and then the ankle is last. Okay. So there in the outliner, you can see is the order that it goes in. Okay. So now we just have to attach all of the controllers and IKs to the appropriate locator, and we're done. That's all you need to do, except that we have no way to drive it, which will be channels in the foot as we did with the fingers earlier. Okay. So first, let's have the IK handle controlled by the ankle locator in each case. So it's a constraint just like any other. We really could parent at this point because IKs and locators are part of a different category, but let's keep doing constraints instead. It's a little bit cleaner. So we want the constrainer first, which is the locator and the ankle, and then the constrained, which is the IK left foot handle. And we just want constrain point. Okay, so now if I move this, there you go, you can see it's trying to use its IK handle, but it's a little bit out of range. It's okay. And the feet are not really behaving right now. So then for the ball locator, we want to point constraint the left ball reverse. And for the toe, we want to point constraint the left toe reverse left toe. All these are just point. And for this one, it's just going to be moved by the controller. So we'll parent constrain that because we do want rotation as a part of that. So constrainer, constrained, parent. So what this should mean is if I grab the controller on the ground and move it, the whole foot moves. And if I rotate it, the whole foot rotates until we get out of range, and then it starts to act a little bit weird. There's a different kind of setup if you want to ensure that that doesn't happen, but we're not going to do it. And no matter the angle that I put this at, I should also be able to rotate the locators to get the appropriate kind of foot movement. So all of that appears to be working. So I'm going to reset all of those rotations. And for the main controller, I'm just going to zero them. Don't zero the locators, by the way. They're going to have some transforms. That's fine. As long as they were positioned and frozen before we did this setup, that's all that we care about. Okay, so that's actually completely working now. Let's do that one more time on the opposite foot. So we want the locator, which is going to constrain the IK for the right foot, point. Okay. We want the locator, which is going to constrain the reverse ball for the right, point. We want this locator, which is going to constrain the reverse toe, point. And then finally, we just want the controller to constrain the heel locator as a parent constraint. Okay, so this controller can also move. See, the knee is bending. We didn't do the pole vectors for the knees, but that's an easy last step. And rotate. Our locator can also bend and position our bones. Okay. So I'm going to reset, and zero out the controller. Great. So that's both of the reverse footlocks done. Not too painful. I know it's a very different process there, but this is going to allow us to have extra functionality in the feet. Then I guess finally we just need to set up the pole vectors for the legs and we're all done. So for our IK left foot, IK right foot, make sure, because we've got this rather long list now, we want to keep in mind which ones we're talking about. So this is the left, IK left foot. So constrainer is the pole vector, constrained is the IK handle. And then we do pole vector. I did see the leg jitter a little bit, but it wasn't very much. Especially when you have legs kind of out in these A-frame pose, that happens. As long as when you bend it, it generally points in the right direction, you're fine. And the foot, by the way, is not going to automatically line up with the leg anymore, which is what we want. We have to do that ourselves. Okay. So I'm going to reset the controller and reset the knee if I moved it. Looks like I didn't. Then finally, the last one, and our IK right foot, constrain, pole vector. I don't know if you saw it, just a little tiny bit of movement, but nothing too concerning. There we go, all set. So that should be everything except for parenting the structure to the lower ring. So let me just do a quick check through. Good time to increment and save, by the way. So we can move the primary body. The elbows, the shoulders are not moving along with it. So that must have been one that I missed. So the shoulder control should be parented to the chest control. So if I move the chest, there we go. Now the shoulders move. Okay. So now let's test again. So if I move my root, the whole upper body moves except for arms and elbows. Okay. If I move my hand, the fingers move along with it. Okay, the elbow can bend. The elbow can bend. I don't really like how the hand rotates when I move this pull vector, and I'm not sure at the moment how to fix that. But that is definitely something that I would change about this setup. It means that you can oppose your hand like this, and then as soon as the pull vector moves, it twists out of the grip, basically. So that's definitely a pretty big failing of this setup. If I figure out how to fix that, I'll show you guys. But just note for now, nothing's wrong with your setup. That's just how I instructed you. So let me reset all those. Okay, all the head stuff we did earlier. The look at control. The hip swivel should now work because we've got IKs. There we go. And then finally, we have our foot controls. We never drove the locators. That was the last part, the set driven keys for that. Okay, but we can parent everything that needs to be parented to this master control now. So basically everything that can move through free space needs to be parented to this master controller. So the root, definitely. Both feet and both knees, both elbows and both wrists. They all need to be parented to the master controller. So as long as you select the master controller last after you grab all of those and hit P, they should all be parented appropriately. And then finally, the look at control. Only the yellow part parented to master control. So now if I move the master control, the entire rig moves or rotates. That's what we want. We don't want scale, remember, because that is a different animal entirely. But that's all the stuff that we want parented. And it's really great because in our outliner now, if you have the master control collapse, then you don't see all of those tons and tons of controls. There we go. We're going to do something with the rest of this stuff in a moment. Okay. Let's go and do the last thing, which is to create set-driven keys for the feet. So that way we can wrap this up. All right, just as we did before, we're going to add attribute on our controller. And the names of these attributes will be ball roll, toe roll, and I think that's it. We don't even really want a heel roll because we are able to do that with the controller itself. So we'll just do ball roll and toe roll. Ball roll, minimum, I'm going to set just -10 and +10. And maximum. Okay, and we want toe roll. There are other things that we could set up, but it would require more locators and more thought. Not 100, -10, +10. Add, and I'm going to do that to the other side as well. Make sure. Okay, I was just checking that the header of this read correctly when I select that new one without closing. So we want ball roll. Remember to name them the same if you want to do them both at the same time. -10, +10, add, and toe roll. We could also make different controllers to change the positions of these locators, so we could make new NURBS curves if we wanted to, but this is just the way I'm doing it this time. All right, so we want set driven key. We're gonna have to go to our animation menu, key, set driven key option box, load the driver. Here are our 2 channels. And then for driven, it is the specific locator, whichever locator is the one that's going to change. So for ball roll, it's going to be this one. Okay, so load driven, and it's going to be rotate, it looks like X. So ball roll and rotate X with nothing changed at all, we key. And then for negative, that would be this way, which a lot of times you're not even going to really want, but I'm going to do a pretty generous one. If you just keep your eye on the locators, I know that the controller's out of range. It would be like you were hanging with your toes off a cliff. Probably not going to come up, but we'll key that. Okay. And then for positive, it's as compacted as you imagine the foot should ever be. So here would be a very, very extreme toe bend or ball and toe bend forward. And we'll key that. I like to go a little bit too far so that I have the option. Okay, let's 0 that. And then for the toe roll, it's this one. So let's load driven. It should be rotate X, but let's check. Yeah. Load driven and rotate X. And toe roll and key. So for negative toe roll, it's the same thing. It's like going this way. Not usually something you're going to need, but I'm just going to be generous and give it like a 90-degree rotation. Okay. And then for positive, this one you really could want more than 90 degrees because we're peeling off the ground. I'm going to go all the way over to, how about like 180 degrees on this one, just in case. So if I had thought that through, maybe I would have made the maximum greater or the minimum less to keep the amount of change the same, but it's fine. You can see the joint's going nuts because the IK handle keeps getting in and out of range, but it is working properly. So now I can use ball roll and toe roll. And as long as we're not out of the IK handle's range, it's going to behave fine. For most cases, it's going to be perfectly reasonable. All right, let's do the other side. So again, load driver. And then we're going to load driven first on the ball. Rotate X. Ball roll key. Change it to a negative value. And I'm going to make it something like that, like hanging off a cliff. Positive all the way up to 10, as compacted as I dare. Great. 0 that out. Change over to toe roll, load the driven object, rotate X. Just wanted to check. Key it at 0. Negative is going to be 90 degrees for me. Or so. And positive will be 180 degrees just to make sure we've got enough flexibility. We can make this relationship, by the way, infinite if we were using an expression. So if you remember from earlier, the way that we wrote an expression was just one value equals another value. In this case, that's all we do. We'd say that whatever the value is here, and we wouldn't set a minimum or maximum, this equals it, and so then it would just become degrees. So we would be driving the degree rotation in X by this special channel, and there you go. You'd have an infinite relationship, which would be really cool. So if you were interested in setting that up, that's how you would do it. Here we go. We can rotate and move, and now, oops, don't want to be grabbing that anymore. We're going to hide those in a second. Ball roll, there we go, and toe roll. So if we get up to here, imagining that it's peeling off the ground, yeah, or hanging slightly below the level of something, like it's stepping up on some surface, and I can 0 them out just by doing that. and that. There we go. Okay. So if all that's working properly, great time to save or iterate your save. Increment your save. I keep saying iterate. Increment your save. All right, last little cleanup step here. There's our geometry. Right now, by the way, in case you were wondering, the geometry is not doing anything. It's just sitting there. That is going to be the subject of next week's lecture. We're going to make sure the skeleton moves along with our character properly. But we just want to clean this up a little bit. We have our bones layer, and our locators are still visible, okay, because they are not bones. Our IK handles are still visible because they are not bones. We want to put all of that stuff into a group and lock it, okay? It's all pretty easy to find out here. Here are all the IK handles, here are all the locators, and even if you open up their hierarchies, the only things that are inside are constraints. So it's pretty safe to just throw them all into a single group. So I'm going to grab all of them, edit, group, and the name of this group is DNT, do not touch. That is a message and a warning for anyone who's not a rigger. Do not touch what is inside this group. The other thing about this group is it should never move, okay? Your IK handles would be moved and then also controlled by something else, and bad things would result from that. Your locators' positions would be thrown off. This needs to be locked. So we're going to lock all of these. We're not even going to hide them. We're just going to lock them. It's a very clear message to not move and not touch this object. The last thing we're going to do is turn the visibility off. Okay? In that way, we don't even have to put it on a layer. Okay? But it also frees us up to be able to see just the bones and geometry. Okay? Or both together. The last thing we might want to do is put our NURBS controllers, all of our controls, on their own layer so we could turn them on and off more easily. You can do that just by grabbing the master control only and hitting this button over here, which is to create a new layer and assign the objects. This one creates a layer without doing that, so that one. And if I double click, I'm going to name this controls. So we can turn our controls off when we're skinning so that they're not getting in the way. We turn our bones off or when our animation is complete and we just want to watch it play back. We can turn our bones and our controls and our geometry all on, or any combination. So we've got a very convenient, easy to control file now. Okay, so that should be it. I'm just trying to think if there's anything else. I believe we actually do want to put our bones in the do not touch folder also, if I'm remembering, because they should never be moved on their own either. So I'm going to middle mouse drag the root bone into the do not touch folder. Now it's hidden because of that now, which is kind of unfortunate. So if you're going to hide this entire thing as your last step, then now our bones layer does nothing. But really it should be put in there because moving your bones separate from, let's go ahead and reveal this one more time. Moving your bones separate from the controllers that are moving them is bad news also. Okay, so really that should be in there as well. I'm going to go ahead and just leave it outside though because of that problem that we can't see it. So just know that it would be fine to throw them in there. It's also fine to leave them outside because when you bake your animation, you need to have access to your bones and geometry only. But we do have this geometry group with everything in here. I suppose that could also be a candidate for throwing in the do not touch folder. But, you know, again, if it's a hidden folder, now your geometry won't be visible and that sucks. Okay. So there you go. That's how it should all be set up. Geometry, bones, controllers, do not touch. We could put all of that into a group if we were like very anal about it to clean up our outliner, but I don't see a reason to do that. So we're going to save that version. As long as you've done a check that everything is functioning properly, then you're all set for this week. Next week, we'll do the process of paint weighting. so that the skeleton will move along with all this stuff, and then magically you'll kind of have a toy to play with. All right, so hopefully all that went well. Go nice and slow, save often. If you have any problems, then shoot me a message and I'll help you out as best I can. Screenshots help though. Okay, so give me a screenshot if it's something particular. Thank you guys, and I will talk to you next week. All right, one last note for picky people, and I am a picky person. I didn't like how the fingers were becoming misaligned in the arm, and so I fixed it, and I'll show you how I fixed it. Okay, so the wrist was always aligned and fine. It was the fingers that were becoming misaligned, and that was because when I move the elbow, then it can control the position of these bones. And this controller isn't responding to that. It's actually driving this and that would create a loop. It would create a feedback loop, which is bad. So what I've done is not mess with anything having to do with the hand control at all, but just put the finger controls in a group of their own here, and then orient constrained it to this bone. So this bone, the wrist bone, is controlling the orientation of this finger group control. So I just grabbed all of these controllers. Remember, the thumb is in its own group, so just grab the group, grouped it, named it, centered its pivot on this joint, and then made it so that there was a constraint. The constrainer is the joint, the constrained is this group of orient. So now what happens is, as this hand moves around, the fingers are always aligned with the bones. Oh, it looks like it gets a little bit weird. No, actually, it is lined up perfectly. It's just strange because I'm crossing across the shoulder and the IK is freaking out. But now the fingers are always aligned appropriately. This is a good thing because the controllers, although they worked still, need rotate Z to move straight up and down. The bend, it wasn't affected at all, but the individual fingers were looking very, very weird when you tried to animate them. So if you want to fix that, you may. If you don't want to fix that, then I don't blame you. But for a very, very high functioning rig, we need something like that. Okay. So just a last little note for anybody who is very bothered by it. I was, and so I decided to go back and figure out how to fix it. And so now you can too. All right, just one more look over here. Here's the hand group for all of the finger controls, which is constrained by the joint. So this joint, however it rotates or moves, will control the position of all of these other controllers, but you never interact with it. Okay. There you go. I will talk to you guys next week.